Thank you, everyone. So, as I mentioned that we are on the landscape of software 3.0 now. Most of the code that we write today is prompts. Most of the rewrite of the software is written based on the prompts. I've been part of JVO from last 2 years. I've done prompt engineering from more than 1 year now. I've collected all the one tip for everyone who wants to start with prompt engineering. This one tip is enough for everyone to get started with it. That is cool enough. That is to beg LLM until unless you get an answer. You beg LLM that please generate the output what I want, generate it in the JSON format that I want. Beg it until it gives you an answer. Just kidding. So we'll go to the first principles of why do we need prompt engineering. This is the basics of why do we need this prompt engineering techniques, because if you provide a garbage input, the probability of getting a garbage output is high. So we make sure that the basics of the prompt engineering techniques are covered here, so that you can restructure your prompt in such a way that you make sure that you leverage the power of LLM at the best practices that you can get the better out response. So for the status, these are the elements of the prompt. That is how a prompt should be written. You have an instruction that what you want LLM to do. Then you have a context that you provide to set a tone of the model, that how you want the answer to be. You provide the input data so that the LLM can get answer basis of that input data that you give. And then also you have an output indicator so that you tell LLM that I want the answer in a particular format. Uh, Based on the use case scenario. We'll go deep dive into each one of them one by one. First is the instruction. This is the main part of the prompt that you write. That is providing actionable items to LLM. It's providing the what to do for getting the output. So this is the base of how you write the prompt. You add some action verbs in the prompt so that it can provide you answer in a better format. So there are two examples here. One is a vague prompt where you write plan my trip, whereas there is a very specific prompt written here, planning a 5-day budget friendly trip to Kerala in December, include sightseeing, local food experience, and public transport. As you can see, we have asked LLM to plan a 5-day budget trip, which is an actionable items which LLM understands well and then provides output in the format we need. We'll move to the context. So this is what we get if we write the same prompt again and again, and it still doesn't understand. This is a very big problem that we have with LLM. If you don't write a prompt in a particular structure, the probability of getting a wrong output or the not the desired output is high. So write the context, set the tone of the LLM, that how you want the response to be. So here also I have divided into two vague prompts, which is a write a letter to my landlord, but a detailed prompt would be a write a polite but firm letter to my landlord asking for rent reduction. Here you provide the context that I want to write a polite letter to my landlord. Next is the input data. This is the input data that we want LLM to act upon. So a vague prompt here would be write a birthday message, but if you provide the input provide an input that it's for my younger brother who has just turned 18, the chances of you getting an output better is high. The last one, okay, so for the input data, the placement of the input data is also very important in how you structure the prompt. So as LLM works on the attention mechanism, the input data, if you provide the input data at the start of the prompt and the end of the prompt, the chances of it picking up is higher. So we make sure that the instructions are at the top of the prompt or at the bottom of the top prompt, and then as we move forward, we rank the input data that we want more weightage upon at the starting or at the end of the prompt so that we can get better result. And last is the output indicator. Here also we are dividing into two basic prompt is write about the message, but the LLM wouldn't know what I want, whether I want a two-line message or a whole email or could be anything else. So if you provide a output indicator that I want the answer to be in a short two-line humorous birthday message, then the chances of you getting an output better is high. So these are the basics of all the elements of the prompt, how you design the prompt from bottoms up. So taking all into consideration, this is the one prompt that can cover all the things that we can do use to construct a prompt. So start with the context. This is the base of how you want LLM to respond. So I have a problem statement where I want advice from LLM to plan my uh, expenses better. So you set the context right. You said that you are a financial advisor and you want to help me with my expense plan. You provide the instruction that what you want to do. What to do is analyze the following monthly expenses. Input data is you provide the input data to LLM to know that what were the expenses that you made during a month. And then this is the output indicator where you provide the analysis in a JSON format with categories as keys and total amount as values. This indicates LLM to provide the answer in a particular JSON format so that you can get better. So we covered the basics of prompt. Now, how do we construct a prompt with following techniques so that you can get better results? So there are few techniques that have been developed by researchers and also by a few developers that found that how we can construct a prompt that could result better. So we'll cover few of the prompting techniques today. We'll do with zero shot, few shot, chain of thought, and self consistency today. But there are also some advanced prompting techniques like prompt chaining or React, Reason and Act, which could also be helpful if you are designing a software. Okay, so we'll start with the zero shot and few shot prompting techniques. What are they? So we know the how we have constructed a prompt. Now we use these techniques to create a better prompt so that we can get a result. So I've collected two examples here. One of the use cases is sentiment analysis and one is the entity extraction. We construct the prompt in a way we provide the instruction, set the context, provide the input data, and then provide the uh, output indicator. So as you can see at last, I have put a emotions column which indicates how LLM wants to get the results. So in zero shot prompting, we don't provide any examples. We just indicate output indicators we put at the end so that LLM can predict the next token on the basis of it. Um, Same for entity extraction. I wanted dates and events from the basis of the prompt. So this is zero shot prompting. Now there are pros and cons of it. It's very simple. It's very fast iteration basis. You can iterate over it again and again and find out which one works best. Um, there is one risk that we don't have to put any output criteria, which could lead to inconsistent performance. Also, knowledge reliance is only basis of how the LLM has been trained. So that is also one of the things that zero shot prompting has cons about. So to cover some of the cons to get better results, we have few shot prompting where you provide examples to LLM so that you can get better results. So here there's one example of classifying the email basis on spam and not spam. So providing certain examples to LLM, it will help LLM to understand what type of output you want. Also, it will understand how to reason about it and then get the desired answer. So providing some examples of the text data and the output you want will make LLM easily identify what results you want. That is one simple example. Another example could be translate to French. These are very simple examples that we have covered so that we can understand it better. So we want to convert English to French. We have provided we have clear instruction to translate to French. We have few examples and what output we want. So this is called few shot prompting. The pros of it are the output indicators are very much detailed as we have provided the output in the prompt itself so that we can get consistent performance. Also, the format would be also clear as we have provided few examples. We can also do dynamic few shot. That could be a subset of this where you dynamically find out examples that you want for the input data and then provide it as part of it. The cons are that it's higher cost because it requires a huge, or not huge, but few amount of tokens in the input data, which could cost a little bit if we're doing it at scale. Also, there is a pattern bias based on the examples what you provide. There could be a pattern that LLM recognizes and it would be biased based on the examples you provide. So example selection becomes a very important thing when you do few shot prompting. which could also you can use a dynamic few shot if needed. So we'll do some hands-on on Google Colab, so you can access the link.
So most of the people might already be aware about what Google Colab is, but those who are not aware what it is, so basically uh, there is a software called Jupyter Notebooks to execute Python code in the browser itself without needing any kind of other setup on your local machine. So basically, Google Colab provides a way to execute notebooks of Python without anything on local machine. So that's Google Colab. We already sent an instruction to set up the Gemini API key, which is like open and free API key that we can use to execute all the code that we are going to use. The instruction were already provided in the mail, but we will again walk you through the same quickly. But if someone has not done that, get the API keys from AI Studio, uh, Gemini, Google account.
So hope everyone has access to Google Colab. If you want the Google Gemini API key, you can go to this link which is present in the Colab itself, and then generate a key for yourself, and then add it in the secret section of Google Colab and allow the notebook access so that it can provide access this Gemini API and use it for the setup. So you can go and run all for now so that we can get started with the some of the prompts that we have written. It will execute all the things that we need, the pre-setup and all the prompts that we have written, which you can change a little bit and then try it out. What happens when you tweak a prompt a little bit? Okay, I've preloaded some of the cells so that we can get started with the session quickly. There are also some troubleshooting guides if you face any issues. There are also some helper functions here added uh, for getting the input text from the files. There is also there will also downloading one of the two files here. One is the article and one is the resume that we'll be using for our examples. You can pre-run all these steps, and we'll start with the demo for few short and zero short form. We'll start with the basics of how do we write the prompts. So there are mainly two types of section. One is the system prompt and one is the user prompt. System prompt is where you provide the context, where you set the tone, what you want LLM to be. So this is where you can provide a role also to LLM so that it can depict that role and then provide the answer based on the role. So I have asked a simple question about explaining blockchain in simple terms. Without giving a system prompt, it would give an answer, a very detailed answer about what blockchain is and explain it in simple terms. Then if you provide a provide a role of a friendly high school teacher and provide the same user prompt that is explaining blockchain, then it will provide an answer in the format where how a school teacher would explain you about blockchain, which is very nice if you want to learn something basics. It would provide a friendly response in the way how teacher would explain it. Also, you can in the system round you can also style how you want the answer to be. If you want the style to be very concise or very citation style answers, if you want something like that, you can also provide that. Here I wanted a very formal citation style answer similar to what we have in the academics, and here as you can see it provided the citation also here and also provided the reference for the same. So this is also one thing that you can tune in the system prompt so that you can get better answer. There are some also parameters that you can tune models to work upon, which would make sure that will uh, look into more other parameters that you can tune the LLM so that you can get output accordingly. So next is the max output tokens. So you can limit the response to be a fixed length. If you want an output to be within certain characters, then you can provide a max output tokens as the number of tokens, and then the response that you get is within that range. Next is the top peak. This also it's nucleus sampling. This is also similar to how you control the randomness of the output. So if you provide it higher, you will get more diverse. If you provide it lower, you get more predictable deterministic output. So you can tune the top P and temperature together to get the relevant answer based on the use case that you are trying to solve. Um, so here I wanted something a little random because I wanted a startup name for my AI travel assistant. So if I provided I provided top P as zero point 0.8, so it provided more creative answer rather than relying more on deterministic answer. Uh, so for this use case scenario, zero point 0.8 makes sense because we want something very creative as I'm asking for uh, startup name. Another is the thinking budget. This is very specific to what Gemini provides. So Gemini out of the box has reasoning. So if you tune this parameters thinking budget, it would be using it for reason about your input first and then providing the answer. If you have seen any of the reasoning models out there, ChatGPT or Gemini, there's a thinking section where the LLM would think first and then provide you answer. There is the same thing where you tune the parameters so that LLM could reason first and then provide you an answer. So you have a high probability of getting good result as we are also allowing it to reason about it. We'll cover more about in COT how we can tune it uh, via prompt. This is you can do it via model parameters that are available. So if you set it 0, it wouldn't reason that much. You set it greater than 0, the amount of tokens that you provide is the fixed amount of length that it gets to reason about it and then gets the answer. If you put it -1, then based on the input, it will decide what reasoning tokens are required and then reason about the C. So I've added one prompt that how you design a strategy to reduce traffic congestion in a smart city. So I provided all three of the types of parameters: 0, greater than 0, and -1. And you can see in detail how if you provide no thinking, the reason would be very simpler and it will provide the answer. While in the reasoning, if you provide a fixed length of tokens, it will uh, strategize based on the principles and then provide the output. Uh, so this is how you tune the parameters will uh, so that you can get better answer. Now using those prompt elements of prompt and this model parameters, you can design the perfect block of code that would helpful for your use case. So there are few other utilities that are currently here. We have taken one article from Medium, which is freely available. We have done the PDF of it and uploaded, and it will be installed as part of the setup here. You can extract text from it. The idea is to run a zero shot and few shot prompting and find out what works better for our use case. Problem statement is we have a PDF. We want a summarization for that PDF. We want to also get some of the things we want from an article to be. So first is the zero shot prompting, where we structure the prompt. We provide the context right in the system prompt that you are an expert content analysis, and I'm providing you this article in the text format. Based on that, you provide me the answer. So here there is no example format given. We are only relying on the how we have structured the prompt, and then based on the system prompt and user prompt, you will be getting the answer. Also, I've set the temperature to be 0.3 so that it's more deterministic. Uh, and as you can see, based on the article, it provided the output that we needed. I have asked for specific uh, 4 things that I need: a concise summary, practical insights of lessons, technical recommendation or best practices, and target audience and use case. So based on the article text, it will provide me the output format. As I've asked for these 4 things, it has provided me all the 4 details. Now we'll do the same thing with few short prompting. We provide some examples of it. We provide some output indicators. We provide some uh, output formats that we need so that we can see how it performs. So system prompt is same. User prompt, we provide some of the examples that what kind of data input you will get and what output do we need. So as mentioned, we want the output to be in summary and we also want some text out of it. Based on the article, it should also generate some text, which is very similar to how Medium also does the text, and you can search on it. And I provided 3 examples of it, and then the article text. Based on it, it will provide me the answer. So as you can see, it provided me concise summary and all the text that could be generated based on the article text. Also, you can tune the prompt so that you can get the output in a specific format. Most of the time, for software engineers, we use JSON or XML based on the use case. Here, I provided the output format to be in a JSON format with all the keys needed and two examples of it so that it can give better results. So provided two examples, provided the article text. Based on it, I want the output to be tune the parameter a little bit so that I can get better results. And as you can see, we get the output in the JSON format. This works well, but for scaling and for better deterministic output, we generally prefer XML, as LLM is trained on large amounts of HTML data. Text are a very good example that you can use for output format, as the corpus of data that is used for training is most of them text. LLM understands better so that you can get more deterministic output, and parsing is also easy as we have all the libraries available. Your system prompt, your user prompt, then you have examples and how the output you want to be. You provide the um, XML text that you want in the output format. Here I wanted title, summary, insights, and metrics and metadata. We provided two examples of it: article text, tune the temperature and top K and top P based on it, and then we got the XML format answer that we want for our article. So this is how we do few shot and zero shot prompting. Can go to next technique, which is COT.
Thank you, Namsak. We will move to the next prompting technique, which is a chain of thought prompting. As the name suggests, it is kind of how we think in real world when there are scenarios that we want to solve. So the chain of thought is almost similar to that kind of technique, and there are majorly four techniques in chain of thoughts. In chain of thought as well, we have zero shot and few shot. Along with that, the scratchpad and decompositional chain of thought is the additional items that we have as a type. So in the zero shot prompting for chain of thought, we just provide it an input, and we just mention it in the prompt itself that also show your reasoning behind reaching the answer without providing any examples or more inputs. So what it will do is it will go through the question and it will try to reason about it. So basically reasoning are the latest capabilities of very recently introduced models. ChatGPT 3 and 3.5 did not have reasoning capabilities, but more or less all the models that are now coming in the market does have reasoning capabilities. So they will provide proper answer like this. And same goes for the few shot learning for chain of thought. In this, we'll provide examples, and then we'll ask question, and then again we'll say that go through the whole question and reason about it, and show the reasoning step. So this is the example of the same where you have a budget, your per month budget is this much, and then you ask it another question saying that 18,500 is another budget, and reason about it using the examples, and it will give you something around this. So, and the third type is a scratchpad style COT. So as the name itself suggests, scratchpad style COT is something where you have an idea and you want to plan something around like a trip, or for example a software development. So what you say is you give an idea and then you provide some details on what you want to consider while doing the execution, and then you say that use the scratchpad to break down the total cost per person in this specific example. And if I go to the next slide, there is a response. So in the scratchpad, what LLM did responded with is step 1, step 2 for calculation food cost per person, and step 3 and step 4, and then at the end it executed this total. And the last one is the answer for the scratchpad style of COT. And the last is decompositional COT. So basically, in the complex scenarios where a single query will consist of multiple items to be considered before giving a response. So basically, medical use cases are more or less suitable for this kind of thought process of prompting, where the patient has some symptoms, some kind of remedies that needs to be taken, and then the diagnostics around all them. So what we provide is, we will provide it a 3-step that lists potential life-threatening causes, identify key red flags of the symptoms, and then recommend immediate action. So then what the prompt will, what the LLM will do is, it will divide your prompt in 3 different sections. It will execute all of them independently, and then at the end it will combine the response from all of 3 and will give you the response with the chain of thought prompting. So this is the 4 different types of chain of thoughts. So as chain of thought has more advanced use cases, the pros for the chain of thought is, like, it will increase the accuracy of the responses that you will get, because you are providing more details. You are allowing LLM to go through step-by-step execution of the task. And as it will also display all the steps that it has taken to reach the answer, it will make the answer more transparent in terms of how the LLM reached the answer. The error detection is also easier, because you will see all the steps that LLM executed to reach the answer. So debugging that step will be easier, as it is visible. And then a multi-step task, as mentioned, this will be used for executing all the tasks that are multi-steps. So along with the pros, it will bring cons along with it. So resource intensive, because we will need to provide more tokens, and LLM will also utilize number of extra tokens to go through the reasoning steps. Then verbose steps. Yep, we need to write detailed instruction around how to follow all the steps. Error introduction is also there. So if there are 4 or 5 reasoning steps, and the LLM introduce error in first or second step, it will pass through all the steps, and at the end you will probably get a wrong answer if the error is introduced in midway. And then the overkill for a simple task. So if you want a summary for the article, don't use this, because it will go reasoning about it. It will overthink of the about the article, and it will then create a summary. Otherwise, just use a simple 0-shot prompting for that. So okay, so I will switch to the quickly to the Colab to show what we have done for the chain of thought prompting. So these are the points that I already mentioned in the presentation. So 0-shot is basically, as an example, we have a job description for AI software engineer, LLM agentic and agentic system, and we have provided that. Thanks. So we have provided requirements for the job description and the preferred criteria as well. So basically, this is a job description, and what the 0-shot prompting is saying is that you are an expert HR analyst and a technical recruiter specialized in the data science position. And then what we have write as a user prompt is, we want to evaluate how well this candidate's resume is fitting the job description, and then we provide the job description, and then the candidate resume as a text, which we have extracted in the previous step from the files that we have already provided. And then please provide a systematic analysis of how candidate matches the requirement and overall compatibility score out of 10. Specific gaps that needs to be addressed, recommendation for improving the resume. So we execute this, and then 0-shot result is here. So basically, it will provide you the systematic analysis of a candidate match first, and it will go through all the sections that we have in the resume, and then it will try to map them against the job description that we have provided. And then it will also provide you the overall compatibility score, which is like the candidate resume is basically Namsuk's own resume, so it will mainly match the requirement as the AI engineer because he is working as an AI engineer here. So it says 8.5 out of 10. And the specific gaps that we needs to be addressed is years of professional experience. So we have said that notable gap is 3+ years of requirement, but he is like a software engineer with 2 years of experience. So it will say that there is a gap. And then recommendations for improving the resume. So basically this section is something that we have added as a tip. So for example, it analyzed the resume, it identified the gaps, as well as it will also identify the content related formatting or the content related addition that we can do. So this is the list of correct project date. So there is a project mentioned with the Eureka matrix, but it is not mentioning anything around the timeline of that project. So it suggests that you should add the timeline as well. So all other suggestions are around that. And then moving to the few short learning, few short chain of thoughts. What we do is we will provide 2 or 3 examples on what kind of job description is there and what kind of reasoning should be used. This is example 1, and then this is example 2 with 7 step, and then we only have 5 steps over here. So just instruct the LLM that this is the format that we want the output in, and this is the reasoning step that you should follow. So if we execute this and rest of the stuff stays the same, job description as a input and the resume as well. And then if you see the answer here, a few short COT results, job requirements is something that it identified from the input. Preferred is this one that we already provided. And then for that, the reasoning is like education experience level. As we have provided this education experience level and other steps like core language proficiency and the stuff in the reasoning steps that we provided as an example, it has provided us the output in a way which follows the provided example. So core language proficiency, LLM orchestration. So if you have noticed that this is providing examples in terms of what we have provided. So the output is in line with what we want as an step-by-step output. And the first example did not have something like that because we have not provided examples around the COT. Okay, and this is an overall assessment as we have asked it to assess the overall like match for the resume, and that finally is the conclusion. So if you notice that it provides here as 8 out of 10. Previously we did not provided examples, so it identified just the job description and the input resume, but now we have provided examples. So it considered more detailed analysis around database proficiency, language proficiency and all. So the score reduced by 0.5. That is still okay. I will still hire him. Okay, so this is the chain of thought prompting. There is one more technique remaining, which will probably fast forward a bit, looking at the time that we have. Basically, the difference between a simple few short learning is that you provide a simple example in terms of these are the outputs that we will get. In chain of thought few short, what we are doing is we are providing an example with the step-by-step output, that these are the steps that you need to follow to get to the answer. So that's the difference. So this will give more consistent, accurate and detailed answer around what you need, what you have done step by step to get to the answer. Okay. Okay.
The data that we feed, right? So let's say if there is inconsistency in data, let's say if there is XYZ I'm saying at the start of the prompts, and maybe after feeding some data, I'm changing what initially I told, right? Then how that outputs would like change eventually?
Okay, so it will considerably change the output because what we are doing is we are instructing. So take an example of very negative edge case where you are providing completely wrong information as the steps or as an example. So what it will do is it will affect the output of an LLM for your question completely based on those wrong examples. So it will completely derail the output that you expect it to give.
Okay. So my question is more around that. Let's say if in list of animals, I'm including only 3 animals, let's say lion, tiger, and elephant. And then I'm after feeding some prompts about birds and water bodies, like aquatic animals and everything. I am saying the animals list is now lion, tiger, and deer,
Okay.
right? Then it will feed the output would be all the 4 animals, or it would be 3 again.
No, it will. So basically, it also depends on how powerful and how much data the LLM is trained. So LLM has its own knowledge as well.
Right.
So if you mention in the prompt clearly that do not consider anything out of the provided details, it will consider. If you specifically ask it to just consider the input that you have provided, it will just consider that input and give the 3 animals only.
Okay.
That's a possibility. Okay, so I will hand it over to Namsuk. We will have a Q&A session again after the final slide. So the next is self-consistency.
Thank you. So as Rajendra mentioned that there are caveats of using a COT because we ask LLM to reason on a particular path of reasoning steps. We don't want to derail it to only a specific set of reasoning. So what we do is in self-consistency, we use multiple reasoning paths so that we can get answer to it. There are multiple ways to do it. I've done it for this particular example. I've done it in one prompt where I provided the problem statement and I asked LLM to reason about it in different ways. So provided a maths example, I have asked LLM to generate multiple methods for this same example and provide an answer finally. And as you can see, based on the reasoning steps, there are 7 methods that LLM used. It finally picked one box, and out of 7, we got one. We got one of it, which was most repetitive answer. So based on that, as in COT, we only reason about in one direction. The chances of LLM hallucinate at any of the step could be higher, which could lead to wrong answer. So if we can add multiple layers of reasoning in different directions and then collab it all together based on the use case and then get the most probable answer, the chances of it performing is higher. There are multiple ways to do it. You can sample it around temperature. You set it at multiple temperature levels from 0 to 1 and get the answer. You can do it in one prompt that is currently shown here. You can also provide multiple personas as system prompt. You can provide different system prompts for 4 different personas that you want, and then you can do the same self-consistency and then get the result and then pick the highest probable answer that all of them covered. So that is how self-consistency works. It covers all the pros and cons of chain of thought and reiterating on it, how we can leverage AI to give better results, more deterministic. There are also caveats around cons of using this. The most important is the computational cost because we are reasoning it at multiple paths. The token is exponential, not exponential, multiplication high, which could lead to a higher cost. Also, it will also be very overkill for a simpler task. If you want a simple summary, reasoning around 7 different things couldn't be a right set of prompt that you write. And also the time that you get for this type of prompts is also higher as you are reasoning around multiple steps. So that is also the case. That is around self-consistency. We'll move to Google Colab for the same. Okay, so here I've provided one simple prompt similar to what we have shown in the group PPT that we want a sentiment analysis based on the sample data that we have provided. And we have asked it to review on the basis of few criterias and generate multiple reasoning for each and then provide the final sentiment that you do. And here is the user review that I've used to get the answer. And as you can see, it generated multiple analysis steps, picked which one is the highest. As you can see, there are multiple different answers for sentiment. It picked the highest one and got the answer as negative based on the also provided ratio as 2 out of it are negative, overall confidence and all other things. So we ask LLM to reason on multiple steps based on the most probable answer, based on most repetitive answer. We choose one and then provide the answer.
One of the advanced prompt technique is REACT, which is reason and act. So if you provide some data and you write a prompt in a manner where you ask it to reason about provided data and then provide actionable items, that these are the actionable items that can be taken based on what's the output of the reasoning. So that's a very simple explanation, but it is more advanced than normal chain of thought, because it will provide you the actionable items based on what is provided as an input. So we will move to the next session, which is bonus section. So we have covered a lot of techniques around prompt engineering, prompts, how to write a better prompt and all. So with the advancement of AI, there are a lot of application in the market which does the single thing, but it does it well. So there are two things that we are going to cover. One is Napkin and one is Gamma app. So Napkin is basically an application which will allow us to create nice representation and images using just a single simple prompts. So I will move to the Napkin. So basically, this is the advantages of React prompt. As a sample, I have taken it. What I do is like app.napkin.ai, you can sign it up and then you select the text from which you want to generate the representation of an image, and then we will click here. So it will analyze this. It will try to generate an image. It will provide you an option and different styles that you can use to create an image. So all the pros and cons slides that you have seen are generated using Napkin itself. So that will be one of the type of generation over here. So these are the options that we get, and then if I select one of the type, for example, I select the style, it will allow me to customize based on how to update that style in terms of whether it looks very professional, handwritten or something like that. So this is Napkin, and the second one is Gamma app, which I will hand over to Namsuk. Explain.
Everyone would have done presentation. Everyone would have used PPT at one point. So this app allows us to generate presentation based on the prompt. You can write a detailed prompt. It will provide you an outline of it. Based on the outline, you can select, deselect, make some changes as you want, choose a style, and then you can also. I will just move to generate. We did not make any changes for the same. So this is basically a nice app that you can use for starting the presentation. If you want a theme, if you want how you want to style a PPT, this is very tool which could help you with how you want to categorize in the PPT, how you want to generate images. You can also rewrite you can also select the images, and then also you can ask it to change a little bit based on it. So it gives you a high overview of how you want to showcase it, and then you can, if you want a quick PPT, you can also present it. It will be also it provides nice animations from one slide to another. So that could be a good use case if you are trying to generate a PPT. This should be very helpful.
Yeah, but this presentation was not created using this. It was created manually. So okay, so I think we'll move to the Q&A section. So any questions from the stuff that we covered, or we might answer. Okay.
So when you're working with prompts, right, one of the biggest things that at least beginners or even normal developers face is hallucinations. So you've covered a bunch of different techniques today. Techniques stand up against hallucinations, and like how do we prevent using these techniques as well?
So we covered most of the prompt techniques. For starters, we can use few short prompting. You provide the answers that you want based on the examples. It will generate an answer. We also covered reasoning COT, which could also help us with reasoning of the LLM, and you can provide answer. So that is also something that we can use in order to reduce the hallucination, as we are reasoning about the same input query. The probability of getting an better answer or uh, less reduced hallucinate answer would be is high. And also self-consistency, that is also something you can do. If the problem statement is very complex, then self-consistency could be a good prompting engineering technique, so that it can reason over multiple paths and then provide you the most probable answer.
Okay. In addition to that, we also can control the hallucination in terms of parameters that we have explained: top P, temperature, and there is something called top K, which limits the number of considerations or possibilities that it considers while creating and generating the answer. So those are the parameters that you also can tune according to your use case to reduce the hallucination.
Thanks.
Anyone else? Any questions?
What is the difference top P and top? So top P is basically a Templar victory, right? So when LLM is the next token predictor at the end of the day. So whenever the chances of selecting the next token is higher. So when you provide top P, if suppose you have a sentence called "I'm laying on a beach at a dash day at a dash," then it predicts the next token. If you have put a higher nuclei 0.8, suppose in the case, the next probable token would have a probability score. If it would be around 0.56, say, and the next probability would be 0.7, 0.3. Then top P does a nuclei sample where it doesn't take the first token that it predicted. It takes the sample summation of all the predictions dynamically. It gets the top. Suppose the first token had a score of 0.56, next had a 0.3. It takes summation of both, and as we have mentioned, it should be greater than 0.8. The second token will be taken up rather than taking the first token, so that you are being more creative. You are being less deterministic. You provide a less top P example, for example, then the chances of selecting the first token is higher. But when you provide a top P greater than 0.5, then it based on the probabilities of next token, suppose there are 10, the chances of picking third, fourth based on the input that you provide is high, which would determine the output that you do. And top K is basically the next token predictor that you do. So based on the samples, if it for top K, there are, if we put it as 10, which is the number of tokens that you predict. So if you provide more number of tokens, chances of it predicting the most less answer is higher. If you provide top K more, the less prediction, the higher prediction that it has will not be taken, and the lesser probability token would be taken. So that is how.
So basically, top K affects in a way where for every single input, LLM will have multiple predictions. Like it can predict up to a different 100 types of token. If you provide top K, you are controlling that sample size to consider the token from. So if you provide top K as 5, so it will get more predicted 5 tokens, and from that it will choose the best one. And if you provide it 100, it will reason on 100 tokens and then choose the one of them. So if you want to increase the randomness, you can increase the top K as well. Yeah, bit of a effect on the cost, not that much.
We generally don't use top K that much. We avoid doing that, but we use the combination of top P and temperature, which is a set of things that you can experiment based on the use case that you have. If you have a creative problem statement, that you can sample around higher top P and temperature, so that you can get better results. If you are very deterministic, you want to do a scientific analysis, the temperature should be taken as low as possible. Top P should be also as less as possible, so that it can predict the next output easier.
So top P is basically introduced later on top K. So top P is more accurate and powerful in terms of how it affects and controls output. Any other questions?
Hi. So if I have a prompt that will generate SQL based upon the information I provided, and I got some expected result, and I'm not happy with that, and I want to ask again, want a LLM to regenerate my response, then what are the changes required in the prompt itself?
So in the second iteration, if you want the same query which is not working, suppose that is the use case,
Yeah,
right?
in our
The-
first response, I'm not happy with the SQL generated,
yeah. So,
and
when-
I
So-
want to ask again.
so in the reiteration phase, what you can do is you provide the SQL query that is generated.
Hmm.
The error that you got while means iterating or response of the query that
Okay.
you got, and then ask LLM again that you based on this is the query that is generated. This is the error that I got. Please reiterate over it and then provide me a SQL query which would work. So
Okay.
providing this context, providing the input data, provide the past data in the prompt itself, the chances of the next iteration getting better results would be higher. Then you iterate over it third time, you do it in a loop until
Okay.
you get answer or until you pass the top.
Yeah, and this information, like my first wrongly generated query, and what is the error? That is my user prompt or a system
But that would
section?
be a user.
User prompt,
Right.
right?
User prompt.
Yep.
Okay.
So in a normal standard like convention,
Yes.
what we use system prompt is for setting the tone of the chat that you are trying to do, or setting the role
Yes.
of the LLM, that because LLM are large language models, as its name suggests, they can do so many things because they have trained on a lot of data. But for example, you want to ask LLM questions around like school assignment or a college assignment or technology landscape, right? So you ask it to be a teacher. So that is something that you can set as a system prompt. That be a excellent teacher who teaches math, and then ask your question in the system prompt. So LLM will first understand that what is the context. So it will act as a teacher and then provide you the answer. So system prompt is more or less on that lines.
Okay, so in my case, like in my use case, if I want to generate a query for particular database, then I can write in a system prompt, like please use this database as a source or destination to generate query.
Or you can
Or
provide
you can ask it to, but like you are an excellent expert data scientist.
Yeah.
That is something that you ask as a system prompt, and in your user prompt as an input, you provide the database schema. That this is my database table schema, and then generate a query to provide the like selection of the state rows and something like that. Or then you pass a user prompt like give me the top 5 employees of the month. Right. So if the system table schema is available, LLM will likely to predict and create a query that makes more sense and that is optimized.
Okay, and type of database, like if you want to specify, so that is a part of user prompt, right? Not a
Yeah,
system.
that is a part of user
User
prompt. You can include, so say if your database is constant, like you are using Postgres or MongoDB,
MongoDB.
you can still add it to the system prompt, but we as a standard practice usually avoid adding this kind of stuff as a system prompt.
Okay, okay, got it. Thank you.
Excuse me, Mike.
Yeah. So we have seen sometimes LLM comes up with multiple options and they want us to choose from. So is it because refinement in the instructions, input data, or is it something the knowledge of the LLM that
Yeah. So in the ChatGPT console, right?
Yeah.
So basically, there is something called reinforcement learning from human feedback. So that is the feature where OpenAI or another company is trying to rate the outputs that it generates. So if it gives you 3 probable outputs and it asks you to choose the best one. So that is how they try to remodel or retrain their LLM to make it more user friendly in terms of what are the answers that user likes. So that is another concept around how to fine tune or train your models.
Okay.
So normal LLM API calls will not provide something like that because they are like simple LLMs responding to your queries. But these are the ecosystem implemented around the OpenAI or ChatGPT to get more input from the users.
Okay.
Hello, can you hear me?
Yep.
Yes. So I'm very naive to this entire development, AI prompt engineering. So just wanted to know, when you integrate this prompt engineering with any of your application, are we dynamically changing this different techniques during based on the user input, or generally we follow the standard technique throughout the application?
Okay, so basically, these techniques are good or bad in terms of independent single or few queries. But when we try to implement an application, we combine so many techniques to make sense of the use case that we want. So if I'm implementing something around the healthcare use case, right? So it is not possible that the simple few shot or zero shot prompting will work. So we will implement the whole mechanism around identifying the action items from the prompt. So we use chain of thought, we use self-consistency. We combine all the techniques to get the consistent and accurate answer all the time, because production ready systems should not be giving unexpected errors when they are deployed, right? So we combine all these techniques, and there are a lot more techniques to prompt engineering than what we have explained today. So we'll eventually cover it sometime in the future, but yeah, so that is basically the landscape around how we use these techniques for the implementation.
If I'm asking in ChatGPT console directly, then it consider my prompt as a system prompt or user prompt.
It is a user prompt. In ChatGPT console itself, it provides you the capability to set the system prompt. There is an option in the settings itself where you can set the system prompt. So anything that you ask in a chat window is a user prompt.
Okay. And can we change the temperature or top K, etc.?
No,
Console?
in the console you won't be able to change that. The temperature and the stuff is more or less for the developers to develop LLM application using the ChatGPT or any other LLM provider. So they are part of an API offering that they have. Uh,
The problem I face while using ChatGPT is sometimes it's lose the context, even if I chat for hours. So what makes a GPT to lose a context, and how we can tackle it?
So most of the LLMs have a token limit, and it has an attention span. So if the context window is higher, the chances of you losing the context is higher. From my experience, you can do two things. You can ask GPT to summarize your whole conversation and then get to the new chat, and then try to get answer based on the summary and then what input you want. Or otherwise, what you can do is ChatGPT also, you can go to the step where it started hallucinating or started losing context. You can edit that prompt and reiterate over that chat from that particular point of time, so that it can cover the cover all the prompts or all the outputs that it has provided correctly. So from the step it started hallucinating, you can get on the edit section, you can type the prompt again and then get down. That are two ways I think would be helpful.
Okay.
So there is something called a moving window context. So the UI that you are using for GPT has a window of a context. So if your prompt and the answer grows, the window will move down to cover all possible tokens, but it grows larger than the expected size. What will happen is the context that is in the beginning of the chat will go away out of window, and that will be now the LLM does not know what is beyond the window. So that is how your context is getting lost. Any other questions? Super. No questions. I think if there are no questions, thank you.
Right. Thank you so much, everyone, for being an engaged audience today, despite the heavy downpour and the power cuts and whatnot would have come across today. But thank you all so much for the patience that all of you have shown. And thank you, Rajendra and Namsuk, for such an insightful presentation and the guidelines and tips that we've shared with everyone. I hope today gave a lot of practical ideas in how we can get better and smarter responses from AI, and probably learn some techniques in terms of how we ask to get and see better performance in terms of what we can get out of ChatGPT or from your prompts that you might be using in your codes today if you are actively using AI in your application development. Thank you so much, everyone. Please take 2 minutes today to fill out the feedback. It really helps us understand how we can shape these sessions better going forward. If you guys have any suggestions or recommendations on the topics that you think would be more beneficial, then we would definitely like to know about those too. Having said that, I'd like to take a moment to thank our leadership team at Jivio, who have been very encouraging in learning space like this for us to go out and explore and create a community of this sort. Thank you, facilities and marketing team as well, without whose support, the smooth coordination and execution for today's event wouldn't have been possible. Thank you so much. We'll proceed for snacks and maybe continue this conversation with other like-minded people that we have here today in our other office. But before we move, can you please all take a minute we'd like to capture this moment so we can look back at it later and probably see how the community is evolving as we take more and more sessions going forward. Thank you so much.